Hello, myself is Dr. Pravin Bhandari. Today we are going to talk about a topic or a concept, friction factor and friction factor chart. Now, whenever we are studying fluid flow operation or fluid mechanics, then we come across this dimensionless term, friction factor. Now, let us try to understand exactly what it is and how to calculate the friction factor. The contents of this presentation are the concept of friction factor and its dependence on Reynolds number, and friction factor chart, and how it is used to estimate the value of friction factor. After watching this video, you will be able to understand the concept, different types of friction factor, dependence of friction factor, value on nature of flow, and friction factor chart and its application. Now, this friction factor depends upon the Reynolds number, which in turns depend upon velocity of fluid, density of fluid, viscosity of fluid, and diameter of pipe. Now, these four parameters decides the value of Reynolds number, and this Reynolds number thereafter can be used for calculating the friction factor. And now once the friction factor is calculated, we can calculate the head loss. This head loss is also a function of length of pipe. So let us try to understand what is friction factor. So as discussed, it's a dimensionless parameter. The value of friction factor is the function of Reynolds number as well as roughness parameter, and it is denoted by a letter F. Now, what is its definition? So it is defined as the ratio of wall shear to the product of kinetic energy per unit mass and density of fluid. So mathematically, it can be expressed as F is equal to tau W upon rho into U square by 2, where small f is a fanning friction factor. Tau W is a wall shear expressed in a Newton per meter square. U is the average velocity expressed in a meter per second. Now there are two popular friction factor used in a literature. First is Darcy's friction factor, or it is also known as Darcy's Weisbach friction factor. So what it is, basically Darcy's friction factor is equal to 4 into Fanning's friction factor. So FD is equal to 4 into F, where small f is the fanning friction factor. We have seen earlier that it is the ratio of wall shear stress divided by the product of density into kinetic energy per unit mass. Now, this friction factor uh, depends upon the Reynolds number. That is, the value of the friction factor depend upon the nature of the flow, that which is in turn decided by a Reynolds number. So for a laminar flow, um, the fanning friction factor F can be calculated as a 16 upon NRE, whereas the Darcy's friction, that is FD, that is Darcy's friction factor, is equal to 64 upon NRE. So once the Reynolds number is known, we can find out the value of friction factor. In case of the turbulence, the Reynolds number as well as relative roughness affects the value of the friction factor. Now, this friction factor can be calculated either using empirical equation or by using friction factor chart. Now, even though we are discussing about Reynolds number, turbulent flow, but let me tell you that we can use friction factor chart for the calculation of values of friction factor in case of laminar as well as turbulent flow. So empirically, this for a turbulent flow, the friction factor, fanning friction factor is expressed as 0.079 upon nre raised to 0.25. That is, it can be calculated by the formula F is equal to 0.079 upon nre raised to 0.25. Now, this friction factor chart or the value of the friction factor obtained can be calculated by empirically, or it can be calculated using friction factor chart, which makes use of the Reynolds number as well as the dimensionless term relative roughness. Now, what is a friction factor then? Um if you observe, then the friction factor chart is basically it's the graph which represent friction factor as an y coordinate, whereas Reynolds number as a x coordinate. Uh, so the scale is expressed in a logarithmic form, that is in the cycle of 10. So even though it is not shown as a y coordinate, but if you observe the Reynolds number greater than turbulent flow, then you will find over the friction these lines there are some values, fractional value k by d represented in case of turbulent flow. So these k by d values are known as relative roughness, or it represents the relative roughness. This relative roughness is the ratio of roughness parameter. That means it is the projection or projected part inside the pipe, and d is the internal diameter of the pipe. So the length of the projected part divided by the internal diameter gives you a relative roughness, and by using the value of relative roughness and the Reynolds number, we can calculate the values of the uh, friction factor. So once the Reynolds number is determined, we can locate that value of Reynolds number, and if we draw a perpendicular till it intersect the line corresponding to the relative roughness, then that point of intersection um, can be used to find out the values of the friction factor, which can be determined by compare from the y axis. So in case of the laminar flow, you can see only single line here. Laminar flow is written F is equal to 16 upon nre. This single line represent that in this case the value of the friction factor is not affected by the relative roughness. However, as we move from in a transition region, or say from a laminar to a transition or turbulent region, the relative roughness or the roughness inside the pipe affects the value of the friction factor. So in this way, either by empirical formula or by using the friction factor chart, we can determine the value of the fanning friction factor. So the key takeaways after watching this presentation are: the friction factor depend upon nature of flow. In case of turbulent flow, wall roughness also affects the value of friction factor in addition to Reynolds number. And in case of laminar flow, wall roughness does not influence the value of friction factor. I'm sure you must have understood the concept of friction factor, how it can be calculated either by empirical or by using the friction factor chart, and how the value of the friction factor depends upon the roughness inside the pipe and the nature of the flow. And I'm sure you must have understood the concept of friction factor, the concept of Fanning and Darcy's friction factor, the method for calculating the friction factor. For more videos like this, please like, subscribe, and share my YouTube channel, Pravin Bhandari, Nandurdi. Thank you. Thank you for watching this video.